All right, so I'd like to start you off with today a little problem involving technical maintenance, basically. So Jamie here, well, okay, we have Jamie in this class. He's a computer technician, and he want to maintain his company's computer. So here's the schedule that he has to do. He needs to back up the computer files every 3 weeks. So every 3 weeks, he's going to have to back up the files to see what's going on, right? So when is the next time that he has to back up the files again? So 3 weeks. The next one is how many weeks? Which is how many weeks total? 6. And the next? 9, and so on and so on, right? Okay, scan files for viruses, same thing again. The schedule is every 3 weeks. To check the operating system patches, meaning like updates, he will do it every 8 weeks. So if he's going to do that 8 weeks from now, how long will he have to wait before he needs to do another upgrade on the, which is how many weeks has gone by? 16. Okay, and for update viruses, virus software, that is done every 9 weeks. You see what's going on so far, right? So the question here is, how many weeks will it be until he has to perform all of the items on the same week? Okay, if you notice here that the backing up files and then checking for viruses, that's happening every 3 weeks, so there is an overlapping. He has to do that, do the 2 tasks every 3 weeks. Okay, but the real question is, when will he have to do all 4 tasks at one time? Is there a strategy to solve this kind of problem? What do you think? Any idea on how to do this? Yes. Interesting. Very good. Greatest common factor. Or for some of you who wants to do it graphically, do you realize that you can actually do a timeline on this? For instance, if I label this, let's call this the first task, the second one is the second task, third one is the third task, and of course the fourth one is the fourth task. Since the first and the second task happens every 3 weeks, I can just kind of lump them together, right? So look at this. Here's the first and second, and it happens every 3 weeks. So let's say that this is 0 week, this is 3 weeks after. So the next one is 6 weeks after, right? Next one will happen is what? What's going to be after that? 9. So it's basically a multiple of 3. 9, 12, 15, 18, what's that? 21, next? 24, next? And 27, and so on. You can extend it all the way. And for the third task, I use a different color to represent that. The third task, however, that happens every 8 weeks. So let's say 8 weeks is right here. So then the next time what happened is what? 16, which is around here somewhere, and then 24. And notice that at this here, after 24 weeks, he will have to do all 3 tasks at the same time. But then again, I don't see an overlapping of all four tasks yet. So here's my 4th job, or 4th task. Let's write that out. Here's the 4th one. He has to do it every 9 weeks, right? So here's 9 weeks. The next one is what? 18. And that's right there. And notice here it's overlapping with the first and second task at the 9-week marks and 18 weeks mark. You can kind of see the schedule, right? So every 9 weeks he has to perform 3 tasks at the same time. First and second and a 4th task. But I want to find out, when will he have to perform all 4 tasks at the same time? Do we have a number for that? You guys know how to find that. Okay, we know how to find a GCF. And so what is a GCF then? GCF? GCF? Think about that for a moment. Is it really? You're hitting it close when we say GCF. But it's not exactly the GCF that we're looking for. You know what we're finding? LCD. Least common denominator. But denominators, when we say LCD, we have to do with fractions, right? What's another term for LCD when we don't have fractions? Yeah, so we call it LCM. So you know when to use LCM and when to use LCD. They're technically the same value. But LCD is used when we have fraction involved. But LCM is used when we don't have fraction and we're still finding the least common multiple, right? So in this case, what is the least common multiple here? If you have to expand this, when will all 4 tasks align? 27. Well, at 27, the third task will not align because the next one after 24 is what? 32 will align, right? So when is that all going to line up? What do you think? Good. Think about this. Isn't, if you expand it all the way, 8, won't 8 hit 72 when it times it by 9? Won't 9 hit 72 when it times it by 8? And look at, for 3, if you do a 3 times table, when will it hit 72? 14. Is it 14? No, I don't think so. When will it hit 72?
27?
72 and 3, what is that?
24.
Right? So yes, you're right. The common, at least common multiple here, in this case, is 72 weeks after. For him to have to perform all 4 tasks at the same time. But you notice here that if we're going to have to do a timeline on this, it will take us a while, right? And what is a better way for us to find the LCM? Is there a better way?
Yeah.
And you're right, it's involved what we have learned before, and that's why I want to bring up to this point right here. So I'll start with a very easy example. For instance, let's say I have 6 and I have 8, and I want you to go and find the LCM for that. What is the LCM for 6 and 8?
42.
What's the LCM for 6 and 8? 24. How do you get that, right? Let me show you the exact step, and hopefully you will use it to get the LCM all the time. And this is how we do it. It involves this. Remember this? Ladder. What is the GCF here that you can take out? 2. If you take out a 2, what do you have left? 3 and 4, right?
Yeah.
Watch the next step. Before, I just say, oh yeah, this is your GCF. Is that correct? But do you realize that if you take your GCF and multiply the leftover inside, you will get your LCM or LCD if you put it back in the fraction. Watch. If you take the 2 times it by 3 and times it by 4, what do you have? 24. And is that what we look for? You see how that works? Let's try another one. What about 12 and 18? What is the LCM then? Let's say, okay, we take out 6, what do you have left? 2 and 3. Are we done with the GCF?
Yeah.
Is there anything that we can take out anymore?
Yeah.
No, right? If the answer is no, then fine. Look, 6, 2, 3. Multiply them up, what do you have?
26.
What is it?
36.
36. And guess what? That is our LCM. Okay? Any question on how to find the LCM? Don't forget that LCM is technically the same thing as LCD because they're the same value. But LCD is used when we have what? Fractions. Okay? So don't forget that sometimes I will call it LCM, but you have to understand that it is LCD I'm looking for. Alright? Moving on here. Let's take a look at our examples, see how we can get this done. Take a look at this first one. Can we find the LCM for this?
Yes.
What do we do?
Factor.
Okay, let's do that. What is the GCF? What can we take out?
You take out a B.
No, let's take care of our numbers first.
Oh, okay.
What can we take out?
9.
9. If we take out a 9, what do we have left?
3 and 4.
3, a squared, bc. Okay, next? 4.
A, B squared, C squared.
Very good. Are we done with numbers?
Yes.
Good, then move on. If we're done with taking out numbers, let's move on to the variable. What variable can we take out?
A, B,
How many A's?
C.
How many A's?
1.
1 A. How many B?
1 B.
1 B. How many C?
1 C.
Okay. And remember again, for variable, we always take the lowest power, right? Not the highest. With 2 A's over here and 1 A over here, the maximum amount of A that we can take is 1 from each side. And that's what it is when we went out the outside. If we take out the A, how many A's do we have left here?
1.
1. How many B?
0.
How many C?
0.
Okay, move on. Over here, we still have 4, right?
Yeah.
If we take out the A, do we have any A left?
No.
How many B?
1.
1
C. 1.
Okay, are we done?
No.
Are we
Yeah.
done with the taking out part?
Yeah.
Good.
Yeah.
So then what we do is we take the GCF outside, times it by the leftover inside, and what do we have? Let's check it out. There's 9ABC times it by 3A times it by 4BC, which in this case will give us what? What's 12 times 9? 108. And how many A's do we have here?
A squared.
A squared. How many B's?
B squared.
B squared. How many C's?
C squared.
You see it? When we multiply, that's when the power gets incremented or get bigger, depending on the power, of course. When we combine like terms, the power stays the same. The number in front will change. You see, that's the main difference between combining like terms versus multiplying, terms. All right, moving on to the next example here. So we got that. This is, what do we call this again?
Least common multiple.
Least common multiple. If I put this back in a fraction form, what is that called?
Least common denominator.
Very good. All right, so let's try this next one here. Let's see if we can actually get this. What if I have this problem? It's no longer a term. I have multiple terms, but I still want you to find the LCM. Can that be done
Yes.
if it's multiple terms? Well, first of all, the trick for doing something like this is ask yourself, is it completely factored? Look at the first binomial here. Is it completely factored?
Yes.
Is there anything that I can take out? No, fine. Then to indicate that I'm done with that, I put parentheses around it to say, I'm done. There's nothing I can do. Over here, however, look at 6m minus 2. Is there anything that I can do for 6m minus 2?
Yes.
What? Take out a 2. If I take out a 2, what do I have left? 3m minus 1. It's like you're doing a ladder on that too, right? So when you have multiple terms, it is okay for you to do a ladder within a ladder. So now if I have to write it out for you, this is what I have. And I say, go ahead and find the LCM for me. Here's the ladder. Do you see any common terms or common factors?
Yes.
What?
3m.
Don't forget, when you say 3m, you got to say minus 1 too because it belongs together. So you got to say it all at once. So do we see, this is the reason why I asked, do you see any common term, which is one term, or do you see any common factors, which is multiple terms? So do we see anything in common here?
Yes.
3m minus 1.
Thank you for saying that. It's not just 3m, it's together, so it's 3m minus 1. So let's say if I take 3m minus 1 out, what is left?
2.
Just a 2?
Yes.
We have two parts here. If we take out 3m minus 1, what's left here? 1. Don't forget there's always a hidden 1 right there if you don't see it, right? So 1 here and a 2 here. So if I want to find my LCM, what is it going to be? So what's the final answer?
3m minus 1 times 2.
Very good. This right here, guys, is your LCM. Questions on that? On how to find LCM with multiple terms. Do it one more time, and this time I want you to do it on your own. See if you can actually get this done. So here's the problem. I want you to go and find the LCM for that. I have 7x minus 3, that's one side, and I have another 15x plus 30. I want you to find the LCM. Go. Jamie, you done?
This is right.
That's fine. We'll see. Okay, let's explore this. Is 7x minus 3 completely factored?
Yes.
Good. And I put parentheses around it. Next one. Is 15x plus 30 completely factored? No. What can I take out?
15.
5 or 15?
15.
15.
Or 3.
We want to take the maximum, right? Greatest common factors. We have to take out the maximum. In this case, 15 I can take out. What do you have left inside?
X plus 2.
X plus 2. Okay, so that means on one side I have 7x minus 3. On the other side I have 15 times x plus 2. I'm trying to do a ladder on this to see if I can take out any additional common terms or factors. Do we see anything in common here?
Yes.
Okay, see, this is a good thing. Remember I told you that when you put it inside the parentheses, it is
No.
together as a group. So as a group means you better have the exact same thing for you to take out.
No.
X right here is not treated as one separate entity. It's the same thing in this group, so you got to pull them all together. So I'm asking these questions again. Do we see anything in common?
No.
Okay, either by itself or as a group. In this case, it's nothing in common, right? So the only thing in common is a 1, right? That means we're done. That means I have that to multiply, times it by this, which is 7x minus 3, right? What else do I multiply by?
15.
Yes, this whole thing. So can we just say 1 times 15 is 15 right here?
Yes.
And x plus 2. And guess what? This whole thing together is your LCM. That's how you do it. If you see something in common, yeah, go ahead and take it out. But if you don't have anything in common at all, just multiply them all together, and that will form your LCM. Does that make sense? Any questions? Okay, if you have no further questions, here it is. Got a couple problems for you to work on. Okay, go to this one. I have two fractions. I have one with s over 3, and the other one is 2s over 7. We don't have the same denominators yet, do we? Okay, fine. How do we solve for this? Okay, good. LCD this time, see? Because now it's involved fractions, so we have to, instead of saying LCM, we are finding the LCD. But it's technically the same thing. What is the LCD for 3 and 7? 21. So can we just do this? 21 is my new denominator. Is that correct? So this is your old, and this is your new. Your job is to say, if I want to take the old denominator and make it look like the new, what do I have to multiply the old one by?
7.
Okay, so if you multiply the bottom by 7, you would just do that on the top, so that would become 7s. Is that correct? What about the other side? What do you have to multiply 7 by? By 3. So if you multiply the bottom by 3, you have to multiply that top by 3 as well. So the top now becomes 6s. Do we have common denominator? We do. So if we do, what do we do next? At the top, which becomes 13s over,
21.
and there you have it. Done. What question do you have? I hope it made that clear for you in terms of finding the LCD and everything else. Pretty good, right? Okay. And let me show you the next problem here so you can actually figure out what it is. What is the LCD here?
TS.
Very good. They're both different. There's nothing for you to take out, so it's just a product above. So if your LCD is T times S, and once again you compare. If I want to make my old denominator look like the new one, okay. Are you catching on?
Yeah.
It's pretty, I hope straightforward enough. What about this one?
T.
Times T. Now here's the trick. Are you multiplying the T to just this T or the 3 as well?
Both.
Both. Very good. Both term on top will get that T, so therefore it is important that you put that inside parentheses. So what do you have here?
T squared.
T squared,
Plus 3T.
3T on this here,
2S.
2S. And if you look here carefully, do we see anything in common that we can combine on top?
No.
No. If not, we just write it as is. So the final answer, guys, T squared plus 3T plus 2S over TS. We'll try our best to simplify. If we can't do it, leave it. Okay. What question do you have for me? Okay, of course, as you know, it will get a bit more challenging, but the concept is still the same, and hopefully you can actually figure that out. Don't get panicked when you see this, because we have seen this problem before. First thing, you look at your denominators. I didn't say it.
No.
No, fine, they're not the same yet. So we're trying to find the LCD. But before you say, oh, I'm going to go start looking for it, you got to make sure you break everything down. I'm talking breaking everything down until you don't have like the power of square or third or fourth anymore. Factor it out. Do you recognize T squared minus 100? What does that remind you of? What is it? Dots. Difference of two squares, right?
Yeah.
So yes, certain cases you will have to experience that. Oh, sometimes I use Xbox because it's 3 terms. Or in this case, 2 terms, perfect square. I use dots on it. How do you actually take out T squared minus 100 and factor it?
T.
What do you write?
T in parentheses and 2 outside.
So basically, it can be written like this, correct? And because of that, let me just go and rewrite the whole thing for you. What's going to become the bottom?
T minus 10.
T minus 10.
T minus.
They're both minuses?
Plus.
This is dots. Remember, dots mean no middle mean cancel mean opposite sign. So the other one has to be positive. Now on this side, it's a bit trickier. Think about this. Yesterday, we just learned how to rewrite. You see this here, this is a positive 10, and that's a negative T. This is a negative 10 and positive T. So how do we reverse it? Yes.
Put T plus 10 and put negative 1 aside. T plus 10.
T plus 10? Or T minus 10?
Minus 10.
Yeah, because we want to replicate this, right? T minus 10. And we put what outside? Negative 1. And this is what we got. Question so far. Okay, and if you look carefully enough, you realize something that, hey, look, there's a T plus 10 and T plus 10.
Cancel out.
Cancel out. So won't that just becomes 1 over T minus 10? And over here, I have a negative and a negative, which becomes positive, and you end up with just 1 over T minus 10. Is that correct? And now here, look at this problem carefully. Do we need to find the LCD? No.
Oh,
So what's the final answer?
1 over T minus 10. Or T minus 10.
2 over T minus 10. Right? Because 1 plus 1, 2. Okay. What do you think of that? So we come down to our last problem. Yes, let me just go and assure you now that the last problem will be a bit more involved. So be careful and kind of look for it. It looks like this.
Holy.
Okay. All right. Don't panic yet. First thing you see is it's a complicated problem, right? But don't forget, can we break it down?
Yes.
Can we factor?
Yes.
Look at the top triangle over here. What strategy can we work on that one? Xboxing, right. This is we check for like terms, and we check for ordinates, we check for GCF, no GCF take out, and then we look for PST, no PST. So let's do Xbox on the top. What do you put on top?
Negative 5.
Negative 5.
Positive 4.
Positive 4. What times what is negative 5 added to 4? Negative 1 and what? 5. Very good. Because negative 1 times 5 is negative 5. Negative 1 plus 5 is positive 4. We took care of the first. Let's take care of our bottom as well. What do you put here?
Negative 3 on top.
Negative 3 and negative 2. What times what here will give you a negative 3 add up to a negative 2?
3 and 1.
3. Okay, fine. You say 3 and 1. Well, which one has to be a negative?
3.
3. All right. So now can we just go ahead and expand it? And when you expand, it will look like this. X minus 1, x plus 5. The bottom will be x minus 3, x plus 1, correct? Is that true?
Yeah.
And over here is 2 over x plus 1. Okay. So now we look at this carefully enough and say, do we have the LCD yet?
No.
Do they look the same yet for the LCD?
No.
No. How do you find the LCD again?
Multiply.
Don't forget, ladder. Ladder, remember we start with the ladder. So if we're going to do the ladder, what can we take out? Is there anything in common?
X.
Once again,
X plus 1.
if it's just
No.
like a single term,
One.
yeah, it's X. But if X as a whole group, then you got to pull out the entire group out. You got what I'm saying? If this is X plus 1, and you see the X plus 1, yeah, those are called common factors. Then take it out. So do we see that or not?
No.
Is there anything in common?
No.
Look at it.
X plus 1.
This over here you have X minus 3 times X plus 1. Over here you have X plus 1. Do we see anything in common between the two? You see it? It's like over here you have AB, over here you have A. Is there anything in common? A. What I'm trying to get you to understand is instead of having just like a single variable, I can have multiple terms representing, like terms. You know what I'm saying? So, if you look carefully enough, we can say we take out X plus 1, right? Then what do we have left inside?
X minus 3.
X minus 3. And over here? 1. Okay, are we done?
No.
Are we done taking out?
Yeah.
Okay, if we're done, what do? We'll multiply them all, right? Multiply this, times it by 1, we don't really care, it's going to be itself anyway. So what is our LCD?
X plus 1 times it times
There you go. So, let's write it. Our LCD is basically x plus 1, x minus 3. X minus 3, x plus 1. See it? This is our new denominator. This is our old, this is our new. This is our old, this is our new. So let's go ahead and work this out and see what we can actually fill here. Is our old, do we need to multiply anything here to make it look like this? Look at it. Do we need to multiply anything here at all? No. So that means, do we change the top? No. So we just copy it down as is. X minus 1, x plus 5. Over here, let's compare. Do we need to multiply anything to the top to make it look like the new denominator?
Yes.
By what?
X minus 3.
Okay, so that means we also multiply that to the
Top.
top. So don't you have this?
Yes.
Any questions on that?
Cancels out.
Here's the part though. You might want to cancel this out, right? But don't forget, if you cancel this out, you get back to this form. Don't do that. Because our goal is to combine them together because we have the same denominators, right?
Yeah.
So do not cancel anything yet until we have them all on top of one single common denominator. Okay, so hold on canceling out your terms. So let's go back to this carefully here. Is there anything that we can do now to simplify? See, before, if I have like 2x over here and then 3x, I can just combine. Distribute that, but what about this one? You have 2 by 2. What do you do?
Dots.
What do you do? This is 2 times
Box.
2. Box it. You see? So you got to use the right strategy. We know we're multiplying here. It's a 2 by 2, so we got to use a box. Over here is just distributive property, right? So let's do that. Let's do box on this side. Here's the box. Here's x minus 1. Here's x plus 5. When we multiply this, what do we have?
X squared.
X squared. This? Negative 1x. This is the plus, by the way.
Oh,
5x, right?
yeah.
And this is negative 5. Like terms?
Yes.
So I put them together. So now the top will look like this. X squared plus 4x minus 5. Over here, if I distribute this negative, don't forget this is sign right here, it stays with the 2. So negative 2, distribute to each term, what do you have? Negative 2x.
Minus 3.
What's negative 2 times?
No.
Plus
Plus 6.
Plus 6. So that will be the top, isn't it?
Yes.
Now I can put the whole thing over what?
X
X
minus
minus
3.
3.
X minus
plus
3.
1.
X plus 1. And that is your LCD. Is that true? Let's clean up the top. Do you see anything in common?
2x.
Negative 2x and what else?
4x.
4x.
And 4x. What else can I combine?
6 and negative 5.
6 and negative 5. So let's put them all together. I have x squared plus 2x plus 1 on top. And I have x minus 3, x plus 1 on the bottom. Now let me just go ahead and state this very clearly. This is actually correct. It's not wrong. However, for those of you who really want to push it a step further and say, I need to clean up some more because I look here and say, wait, this is not factor, right? Now that I put it this way, can we use Xbox to factor this?
Yeah.
Let's try that. What do we put on top?
1.
1. Bottom?
2.
2. What times what does 1 add up to 2?
1 and 1.
1 and 1. Oh, wait. Is that PSD then?
Yes.
Right? So hopefully someone can recognize this. Here's 1 squared, 1 times 1. That's a perfect square term as well. So it is a PST. But notice that even if you forgot the PST and you went straight to Xbox, it still worked out the same way. So if you go ahead and write it out, don't you have x plus 1 on top? At the bottom, you have x minus 3, x plus 1. Watch what happened. And this is the last part where you say, okay, now we can start canceling out the terms. Look, there's x plus 1, there's x plus 1. What do I have left?
X plus 1 over
X plus 1 over x minus 3. And that completes the entire problem. I know, it's insane, right? It's a lot of work. I know, I realize that. But watch what it's involved though. Factoring, okay, LCD, expansion, combined like terms, and of course more factoring. Everything that we have learned in chapter 8. Okay? Alright, so let me stop that and give you a quiz.